we're told that an AU is an astronomical unit here, which is simply the distance between Sun and the Earth, okay, which would be 1 AU then, okay, and we're told here what that distance is. And then Pluto, which of course is much further out, okay, we're given the distance here for Pluto. So it says, using suitable approximations, estimate the distance of Pluto from the Sun in AU to show that Sean is correct here. Sean is saying that the distance is less than 50 AU. Well, first of all, we need to do suitable approximations. So here I'm going to just say 6 times 10 to the power 9 kilometers. That would make sense. That's pretty close to 6. And with the AU, you could see then that will be 1.5, yeah, times 10 to the power 8. So that's what I'd be looking at there in terms of approximations. Now, what we need to do then is take the distance of Pluto, 6 times 10 to the power of 9, and we need to see how many AU this is. So in other words, how many of these we can fit in here, okay? So we need to divide this whole distance here by the length of AU, which is 1.5 times 10 to the power 8. This actually can be done nicely, because when you're dividing here without a calculator, you could just first of all divide the numbers. Now 6 divided by 1.5 is actually really easy, because if you think about it, 1.5 goes into 6 exactly 4 times, okay? And then when you divide in the powers of 10, just use rules of indices, okay? So 10 to the power 9 divided by 10 to the power 8. Well, of course, then you've got to take away the powers when you're dividing, yeah? 9 take away 8, so we get 4 then times 10. 9 take away 8 is 1. So 10 to the power 1 is just 10. So 4 times 10 is 40. So in other words, you can fit 40 AUs in that distance. So we could say the distance is approximately 40 AU. So in this case, Sean is right, isn't he? Sean is correct, because it is less than 50. It says then a light year is the distance light travels in 1 year. So 1 light year is approximately 63,000 AU. Estimate the length of a light year in kilometers. Well, what we need to do here is 63,000. Well, we could sort of think of that as a 60,000 in terms of estimating, okay? Because it does say estimate the length of a light year in kilometers. So we take 60,000 AU, and because we know AU is, what do we have here, 1.5 times 10 to the 8, that's 1 AU. We can just times this by 60,000 to get the length of a light year. So 60,000 times 1.5 times 10 to the 8. Now what I'm tempted to do here is just times these together, because if you think about it, 1.5 is 1.5. So 1.5 of 60,000 is going to be 90,000. Because a half of 60,000 is 30,000. So 1.5 of 60,000 is 90,000 times 10 to the power of 8. Write this in standard form then. So we've got 9 times 10 to the power of 4. That's what that would be in standard form. The decimal point moves 4 places. Times 10 to the power of 8. And then we can put these together. Again, using rules of indices, when you're multiplying, you add the powers, don't you? So we get to the power 12 there. And there's our distance in kilometers.